All right, here we have number 6. You're going to find the value of the unknown variables. Okay, the objects here are different, so make sure you understand which one's the transversal. Okay, first of all, it looks like we can get an easy one first, and that looks like this, because this does form a line, a linear pair. So looks like 2x plus 90 plus x, that does equal to 180. So 3x plus 90 equals to 180. If you minus 90 to both sides, you get 3x equals to 90. Divide by 3, divide by 3, x is equal to 30. Okay? Now, looks like this is parallel to this, right? So if we extend this as the transversal, right? Notice this is 30, so by corresponding, this also has to be 30. By linear pair, this has to be 180, so this has to be 150. So z is going to be 150, okay? Also, notice if this is 30, and this is its vertical, we can then say that 2y is equal to 30. So y equals to 15, and that is because of vertical angles, right? Let's look at B. So for B, it looks like we have two lines that are parallel, and there's this weird bent here. So what you want to do is you want to extend this line. Okay, so this can be one transversal, okay? And then this could be another transversal, doesn't matter, okay? We can call that T2 if you want. Also notice, right, that depending on how you see it, okay, you can draw an extra line here that's just parallel to the other ones, because notice, as long as we do that, you can. That's called an auxiliary line, okay? All right, so let's see how, those are all the different things you can do to it, okay? So let's see how we can get the x. Well, it looks like if we get 50 here, we can also, if we drew an auxiliary line here, we can say that this is also 50 right here because of corresponding, right? Because this and this are congruent, right? If this is the transversal, we call that T2. But also, if we went like this, okay, all right, and notice that I get, let's say I get this part. This part is 80, right? That means this is also corresponding to be 80. So that x is right here. The x is made up of these two. It's made up of that 50 plus that 80. So x is going to be 8, 9, 10, 11, 12, 13, 130 degrees. That comes from drawing this auxiliary line that is parallel to the top line and the bottom line. Let's look at C now, okay? So it depends on which one you want to treat as the transversal here. So let's just extend the lines a little bit more so we can get a better image. So we can say that line is parallel to this line. Okay, let's see if we can get anything here. Well, we can extend this as the transversal, okay, and then that would make this top part for y, but that's useless. What else could we do here? Let's think. Maybe we can draw another transversal. So let's say this is the this is a transversal line here. Let's see if that's useful. Well, it does look useful. Okay, notice that this angle here has to be corresponding to this angle here. So this is 3x, but that is vertical to this. So 5x minus 20 is equal to 3x. So we can actually solve minus 2x both sides. This cancels, this becomes 3x. Then we add 20 to both sides. This cancels. This becomes, oh sorry, minus 3x. And then this becomes 2x, and this becomes a 20. Divide by 2 to both sides. X is equal to 10. You see, we got that there. So we got that by looking at that transversal. Let's see if we can somehow get the y. Ooh, this is interesting. What happens if I plug in a x in here? What is that? So 5 parentheses 10 minus 20. This becomes 50 minus 20. So this is 30. So this whole thing is 30 degrees. Isn't this part here a triangle? Right? Yeah, that is a triangle. So why don't I do 2y plus 4y plus that 30 degrees equal to 180? So this is 6y plus 30 is equal to 180. Minus 30 to both sides. This cancels. 6y equals to 150. Divide by 6, divide by 6. That should work out very pretty. Okay, we have 150 divided by 6. That gets us y is equal to 25. There you go.